This is the 10-Minute Teacher Podcast with your host, Vicki Davis.
Today's sponsor is Clixo. Clixo is an amazing magnetic steam toy that I recommend for classrooms and kids everywhere. Stay tuned at the end of the show to learn more about Clixo, or check them out at clixo.com/pages/target. Today we're talking with Dan Finkel. He is the founder of Math for Love, a Seattle-based organization dedicated to transforming mathematics education. He has a PhD in algebraic geometry from the University of Washington. He creates engaging math curricula and games, including the award-winning Prime Climb and Tiny Polka Dot. He is a prolific puzzle author. He's contributed to TED Ed and the New York Times, and he gives numerous keynotes all over the place about innovative math teaching methods. So, Dan, we want to talk about math and making it exciting. What gets you going about this topic?
Math is a topic, I think, that I personally was just drawn to it as a young kid, but I think at first it was just something I was pretty good at. And I think there's a certain pleasure in just being able to do something and be competent at it. But I had a kind of awakening around it thanks to a math camp when I was in high school, where I started to see it as a really different type of subject that was part art form, part kind of community experience, and just something that was much more deep and beautiful and profound than I had ever realized before. And ever since then, I think I have had an interest in trying to share that experience of what mathematics can really be like, which is not just this helps me do my taxes, or this kind of solves real world problems for me, though it does that also, but this transforms how I see the world. This makes me powerful in a way I didn't know I could be powerful. And I just don't know of a comparable experience to doing math. I don't know of something that is so empowering and enabling and beautiful. So I just feel like everyone deserves to have that in their life, at least a little bit, at least to know that it's there for them if they want.
So you talk about math as play.
Mm-hmm.
If you really believe that, how can we bring that to every classroom? Because so many people don't see math as play or fun or exciting.
I think it's well understood that young children learn through playing. Pre-K kids, definitely. There's no disputes about that. I think everyone understands that. But then you also have some of my mathematical heroes, John Conway or Martin Gardner, are people who connect mathematics and games and playing. And it just seems like it's a strange thing that we basically say there's all these really fun, playful, amazing experiences in math, but you have to do 13 years of drudge work before you're allowed to see them. And we've rooted out so many people who I think would respond to that. So my experience is that when you can let mathematics be, when you can essentially invite students into playing with mathematics, they have a qualitatively different kind of experience, and they learn more deeply. They learn more powerfully, and they're more likely to just like math, like being there. What people who I take this approach and use our lesson plans, and what we hear is the kids wanted to stay in at recess to finish doing whatever we were doing at math.
Oh.
Do you know what I mean? And it's not, okay, now you're done with this so you can go play. It's you are playing and you don't want to let the play go.
Oh, fun.
And you could switch to another kind of playing, but I just think that play is one of the kind of aces in the hole that we have when it comes to teaching math that we just don't use enough. And inviting kids to play with mathematics, if you can do that, can actually lead to more rigorous and more enjoyable experiences for everyone.
You talk about that most math classes start with answers and that we're starting the wrong way. How should we be starting math?
If you start with an answer, you're basically saying, okay, you need to know how to do this thing. You're basically starting without context. What you should do is start with a question, because or a prompt that elicits a question from students, because what you really want is to help students get curious. You start with questions, it just contextualizes what you're doing. It is the way of doing math that humans have always done math, which is they get curious about something and they figure it out. And it brings up the curiosity of the students, which is somehow the fuel for learning in the first place. And it's very hard to drive the classroom forward when you don't have that fuel in the tank, which is kids being interested, being curious about how things work and what's going on you kind of collect sometimes what are particularly rich questions or rich avenues. One that I like is thinking about the Pythagorean theorem, which is often given as like, here's just this weird fact. What does it mean? Why does it mean anything? Why do we care? But you can motivate that totally differently by looking at squares on a grid. And most squares are just square numbers, 1, 4, 9. But you can also tilt the squares. And suddenly you have a tilted square that's up on its, on a diagonal a little bit. And you say, well, how big is that square? And people will cut it into pieces and try to figure it out. And I found that you can have a beautiful experience with students that leads them to the Pythagorean theorem if you just start by saying, let's try to find how big the squares are that we can draw on a grid. And some of the squares are just right side up, and it's 1, 4, which is a 2 by 2 square, 9, which is a 3 by 3 square. But if you start tilting them, it becomes very interesting to say, well, how could we figure out how big those squares are? And maybe you cut them into pieces, and it gets a little laborious and a little technical to try to figure out what it is. But you start to find patterns and a structure underneath. And you can actually very naturally go to a proof of the Pythagorean theorem from that. And I think the people who experience it that way don't have this disconnected fact of, oh, for some reason, a squared plus b squared equals c squared. They actually have a connection of ideas and arguments leading them to understand what's really happening there. A professor of mine once said, memorize arguments, not facts. And in a way, that's what we want to do. Is this isn't just some disconnected thing. This is a body of knowledge where each new idea is motivated by the questions.
How do we help our students value the productive struggle required to learn math?
I think there needs to be a perception that struggle is just part of doing math. And if math is just coming up with the right answer, if math is just saying, here's this question, and a computer could look at it and solve it and say, oh, here's the answer for you, and you pass it on. That's missing what I think the mathematical experience is. So what we really want, I think, is to say part of learning math and doing math, and that starts with play and playing around, will often involve bumping into something where you just don't quite know what to do. You're playing around, you notice something, you notice a pattern. There seems to be some behavior that feels right or feels true, but you can't quite explain it. Or maybe you have two different intuitions about something. And if you get an answer at the wrong time, it deflates the tension and it makes the whole experience flat. And the struggle is actually part of what animates the mathematical experience and makes it fun. So you want to keep it productive by having it still be successful, by feeling like you actually have had previous success, you have momentum, you have things you can do. You definitely don't want to have a classroom where kids are just hitting a brick wall over and over and over and over again. Like it can, you can get to despair very quickly. So you want it to be positive. You want it to be, there's a sense that you're always getting more feedback, more ideas, more movement. But also there will be problems that just are not fully resolved. And I think when we give students a sense that mathematics is basically complete, we know all the answers, you just need to get the answers. That's not what mathematics is. Mathematics is something where we've been able to figure out a few things through really beautiful ideas, and there's a ton still to be figured out. There are so many unsolved problems in mathematics, and just to have a sense that this isn't about we know everything, your math teacher knows everything, and you just need to know what we know. This is, you are fundamentally coming up on the limits of human understanding, and maybe we can push them a little bit further. So even if students are learning something that's a body of knowledge, to have it feel like that a little bit can be powerful.
So travel back in time, Dan Finkel, first day of working with teaching math and this whole thing. What would you tell him about teaching math to help his process move along faster?
It's funny. I was teaching 5 preps and I was very improvisational. I was learning a lot. And was also teaching a sixth grade class at the same time. My second year, I had a fourth grade class, which, yeah, I think, what I probably would have said, looking back, I think there were some colleagues who I was really drawn to and who I learned a lot from. And I would go into their rooms and observe sometimes and see what's going on. I think what I would tell myself is that I should have been looking at even more of my colleagues. I should have been observing more of their classes. And especially, I now love elementary level mathematics, and I spend a lot of my time in that world. But I think there were structures in place that those elementary school teachers understood that I didn't. And so when I was teaching fourth grade, I was really challenging for me at first. And I think that would have helped me learn faster if I'd just been paying attention to more of the people and not just the people who sort of had that razzle dazzle that got me, especially in the beginning.
Well, there are those who think that we can AI automate math. What's your response?
I predict, and we'll see if I'm wrong about this because AI surprises people, but I predict that teaching will be one of the last things, one of the holdouts that's harder than anyone thinks to automate. There's been other things over the years, Wikipedia and other things, where a motivated student might be able to use it to learn a lot. Teaching is one of the great misunderstood professions because it's so complex. It's so interesting. You can be so good at it and then get a new class and it's just a totally different puzzle. We're talking about productive struggle, like teaching.
Yeah, and you're a noob all over again. It's like, I thought I knew this stuff, and why do I feel like a beginner? You know?
No, totally. You're like, how do I solve this student in this group culture? Like, if it were just let's assemble the facts and hand them over, it would be so easy. But it's not that. You're designing experiences and trying to create a culture where people will want to partake of those experiences. And it's so much subtler and so much harder, I think, than people give it credit for. So, maybe there are ways to use AI, and maybe teachers will come up with some clever ways to use it to help them in that. But the idea that I will replace teachers, I think, is just a pipe dream as of right now. I keep feeling like people have thought that they could just get into education and solve it. And it is just so deep and subtle. And in a way, I wish that instead of, trying to do things more efficiently and more cheaply and stretching teachers further, people just said, this is just a hard but important project and we should just invest in it. And I just feel like if we had been doing that rather than trying to find some magic bullet shortcut over the last 40, 50, 60 years, things could really be different in education.
Yeah, cut out the standardized testing and raise teachers' pay with that money. I mean, there's so many things that people keep trying to find the quick and easy fix. But anybody who has a child knows quick and easy and fix do not go together when you talk about children.
That's right. I'm very skeptical as of right now that we're going to see that kind of breakthrough that people are hoping to get in AI. And personally, I even don't do that much, especially with elementary school kids. I tend to not even do stuff on computers with them. I feel like hands-on work with young children is way more valuable. There are ways to take, polypad and roll 100 dice at the same time, and you can collect data. But with young kids, like maybe from middle schoolers and high schoolers, it's nice to do that. But for young kids, there's a real value in just rolling the dice themselves.
Yeah, manipulatives.
That there's valuable work happening there that I think people can lose if they go too quickly to the screen or to abstraction in general.
Dan Finkel, Math for Love, as well as a very popular TED Talk, 5 Principles of Extraordinary Math Teaching. That's one of those that I think all math teachers should listen to. Today's sponsor is Clixo, an award-winning magnetic play toy that turns 2D shapes into endless 3D possibilities. I recently took Clixo to my classroom. A few students started playing, and then eventually the whole class was on that side of the room, designing, making crowns with propellers, sea animals, and anything they could dream up. Clixo is a magnetic play system, and it has flexible pieces that make it simple for students or kids at home to build, explore, and collaborate in the classroom, on a field trip, or at home. I love the design challenges that come in the box, but it did not take long for my students to be creating designs of their own. We tested the Creator Pack, which is full of ball bearings to let them add cute spinning things to their creation. We also tested marine marvels with amazing sea creatures and the tiny and mighty space that was easy for travel. And it's super easy to clean up. I highly recommend the Clixo for elementary centers. Makerspaces for elementary through high school is amazing no-screen activities for kids at home or traveling. These will make great holiday presents. So check them out at Clixo.com/pages/Target. I highly recommend Clixo as a great holiday present or for your Makerspace or center. Check out Clixo. Thanks for tuning in to the 10-Minute Teacher Podcast. Watch the video version of this podcast and catch my new radio and TV show, Cool Cat Teacher Talk, on YouTube and a radio or TV station near you. Join my Cool Cat Teacher Classroom Matters newsletter at coolcatteacher.com/newsletter. Leave a review if you found this helpful. See you later, educator.